It's the boom boom. 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 The boom boom. Listen. When your mama get back to you, did she pray? Pray. Not enough. Pray, she must have made you for the best you could ever be.
So,
That here.
yeah, stay tuned now as we start today's class. It's going to be, I will assume that you've never been taught set theory before, but I'm going to explain the rudiments of everything that you're going to meet in WAHEC, in external exams, in final exams, so that whenever you see any question relating to set theory, you will be able to tackle it. So let me be sharing the screen with you now. And as I begin to explain, you might not need to put anything down for now until when I say you should do so. Is that taken?
Yes, sir.
So please just be patient and listen along. Now, can you see the whiteboard now?
Yes, sir.
Very good. So I'm going to be sharing. I'm going to be writing. I write the topic right away so that you can see what we have for today. I said that is a set theory. Set theory. So, have you had anything called set before? Set in mathematics.
Yes, sir.
Okay. So, what do you think set is? What do you think it means when we come to mathematics? Just in your
Like
own
it's
way.
a list of,
Yes. Yes.
like it's a list of items in something, like a list of
Okay.
animals.
You're on the way. Yeah. Let's say like a list of elements in a certain group. Yeah, like a
Yes.
list of elements in a certain group. So, anyway, you just said something now. You said a list of elements in certain groups. That means
Yes, sir.
elements must be in a group. Then they must be related. Is that not so?
Yes, sir.
So what is related should be grouped together, and what is not related should be grouped together. So in that way, I can say that set is a group. Set is a group of well-defined objects. What do I call set?
It's a group of well-defined objects.
Yes, very good. It's a group of well-defined objects. So we're going to be looking at an example of well-defined objects. The term well-defined object here simply means related objects. Related objects. So
Okay.
related objects that are similar, objects that have similarities, something that unite them together, that we can say they go along together. So let's look at examples now of what we call sets. So example of set that when you see, you can know that okay, this is a set. Number one, I can talk about maybe I can talk about list of numbers. List of numbers. Then I can also say list of even numbers. List of even numbers. I can also move ahead and say list of alphabets, like the consonants or the vowels in English language letters. So list of a kind of alphabet like vowels. List of vowels. Then we can talk about list of the months of the year. The months of the year and yes, the months of the year, and also days of the week, and so on and so forth. So these are examples of sets. Now, In which format do we, encounter questions on set? I'm going to be explaining by solving some real life example or examples with you. The first one I'm going to be solving, I'm going to clear the screen now. The first one I'm going to be solving is this. Let me write this out for you. Let's say examples. Yeah, set examples. So, examples on set theory. Examples on set theory. Now, number one, given that set universal equal to 1 to 20. List of numbers from 1 to 20. And from the universal, given that set A equal to all prime numbers in the universal. So all prime numbers. And set B, all factors of 60. All factors of 60. I mean set B, not set A this time around. So let me try to erase that. Set B, all factors of 60. Then set C is all multiples of 4. All multiples of 3. All multiples of 3. Now, let's say the question says A, represent the set in a Venn diagram. Represent the set in a Venn diagram. Let me write that Venn. Venn is VENN. Venn diagram. So the question is, what do I need to do? Then the second one is maybe you have to find some things from the given set. Let's say you have to find Roman figure 1, maybe A intersection B intersection C, the Roman figure 2, maybe just A intersection B, the Roman figure 3, A union C. Okay, if these are the things you will have to find from all of this, or let's say Roman figure 4, let's write one more question there. Roman figure 4, let's say you will have to find something like A union B union C complement, A union B union C complement. So how many questions are we asked to find now, apart from representing in Venn diagram?
4.
4, very good. So, given this, let me try to save somewhere because I want to clear the screen, and so that I'll be able to take it one after the other. So, the very first thing we have to find is to draw a Venn diagram to represent all this information. We cannot draw the Venn diagram if we do not know the exact element of A, the exact element of B, and the exact element of C. Because I have not written any element in A, B, or C. I've only defined the properties of the element. Is that taken?
Yes.
Very good. So I'm going to clear the screen now. Then we start with A to list all the prime numbers that exist from 1 to 20. All the prime numbers that exist from 1 to 20. So let's say solution solution. Now, we want to identify all the elements that are present in subset A. So now, A says A is all prime numbers. All prime numbers. Now, what are prime numbers? Do you know what prime numbers are?
Number that can divide 2.
Okay, number that can divide 2. Not really. Not really.
And
prime
itself.
2 and itself. Okay, can you try again? What are prime numbers?
All numbers are numbers that can divide 2 and itself.
Okay, definitely. You have an idea, but that is not the correct answer. The correct answer is that prime numbers are numbers that have only 2 factors. They are divisible by 1 and themselves alone. A prime number is divisible by 1 and itself alone. Can you repeat that?
Yes.
Oh yeah, repeat that. Let me
A
hear.
prime number is a number that can be divided by 1 and itself.
Very
alone.
good. It is divisible by only 1 and itself. So, talking about 1 to 20, which is our universal, our universal set is 1 to 20. All the numbers from 1 to 20. 1 to 20. So, now, let us now begin to consider this 1 by 1 from 1 to 20. Is 1 a prime number? Obviously, 1 is not a prime number. Why? Because 1 is divisible by 1, and it's also divisible by itself. Itself and 1, they are the same. So that nullifies 1 because it must be 2 different factors. Are you getting that?
Yes, sir.
Very good. So 1 is not a prime number. But let's consider 2. 2 is a prime number. Why? Because only 2 and 1 can divide 2. Nothing else can divide 2. Is that clear to you?
Yes, sir.
So 3 is a prime number. Why? Only 1 and 3 can divide 3. Nothing else can divide 3. Is that clear?
Yes, sir.
Now, 4 is not a prime number. Why? Because apart from 1 and 4, 2 can also divide 4. Is that a hint?
Yes, sir.
So what is the next prime number now?
5.
5. What's the next?
7.
Yes, next.
9.
9 is not, because 3 can divide 9.
No,
apart from
sorry.
Yes, what's the next?
Yes.
What's the next?
11.
11. Yes, what's the next one?
13.
13. Yes, the next prime number?
17.
Very good. 17. What's the next prime number? Now we're going to 20 now. So what's the next prime number?
19.
19. Very good. And that ends the list of the elements of A. How did we get all these numbers? Because properties of the elements of A has been stated for us. Yes or no?
Yes, sir.
Now let's go to elements of B. So elements of B says B are all the factors of 60 that exist from 1 to 20. So what are the numbers that can divide 60 that exist from 1 to 20? So I have 1. The next one is what?
2.
Yes. What's the next?
2.
Hey, what's the next? Yes.
3.
3. Next.
5.
Okay, what about 4?
4. Yes, 4.
4. Very good. Then next 5. What's next?
5. 6.
Yes.
6.
Yes. Next.
8.
8 it's not a factor of 60.
Okay. 10.
10. Good. Yes. Next.
12.
12. Next.
13.
Now let me show you a very quick way. Look at the screen. Yes. Now, look at this. Since you get to 6, that is the halfway. 6 times 10 give me what?
60.
And 5 times 12 give me what?
60.
And 4 times 15 is going to give me 60. Is that taken?
Okay, sir.
Then 3 times 20 is going to give me 60. Then 2 times what? 30. Then 1 times what? 60. So that is how to get the factors, okay?
Well, you say from 1 to 20.
Oh, I've jumped to 30 and whatever. So let's assume you want to list all the factors of 60. It will include what? 30 and 60. Is that taken?
60.
Yes.
Yes, sir.
But right now, we don't need that because our universal is 1 to 20. So what's our last element there? 20, right?
20.
Very
Yes, sir.
20. So I'm just showing you how to get all the factors of a given number. Let's assume you will have to get it. So like, 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. Okay, now let's go to the element of C, subset C. So subset C has been defined for us. It says it is all multiples of 3 that exist within the universal. It's all multiples of 3. So what are the multiples of 3? We have 3, yes. 6, yes. 9, what's next?
12.
Next.
12.
Next. 15.
What's
Next. Next is what? 20. 18. Not 20.
20.
So we have 3, 6, 9, 12, 15, and 18. So that's all. Those are the elements. Now let's go back to our question. The question says, represent these in a Venn diagram. Venn diagram. Let's draw a Venn diagram. Venn diagram. To draw your Venn diagram, you're just going to have like a big rectangular box. The square can be rectangle or something like this that you're going to close with your universal. And our universal is 1 to 20. Then we have to represent the 3 sets. So let's assume this is the first one, set A. This is the second one, set B. Please look at it. And this is the third one, set C. So for set A, B, and C, we need to check the common elements of each set. Let's check what is common to A and B and C. That is A intersection B intersection C. What are the elements that we can find in A, we can find in B, and we can find in C? There is 1 in B. There's no 1 in A and C. So 1 is not common. Is that taken?
Start from 3.
Yes, it starts from 3. So the first is 3. So what next? What else is common? Is there anything else that is common?
That is all.
That's all. Okay, so let's assume that's all. Then we say this is the region for A intersection B intersection C. Is there any other thing common?
No.
Okay, so this is the region. Look at it. This is the region for A intersection B intersection C. So you put 3 there. So when I put 3 here, please don't write anything. You are going to get the lecture video later. Okay?
Okay.
So don't write anything. So just focus on the explanation. Now, A intersection B intersection C is 3. That's why I put the 3 at the middle there. Now, let's now go for A intersection B only. A intersection B. So what is in A and is in B? 2,
2,
3.
3,
What else? 5. What else?
That is all.
Nothing more. So, okay, I'm hearing background noise from your side. So now 2, 3, and 5. Look at the circle of A and B. Can you see the circle?
Yes, sir.
Now, we have already 3 here, so we need only 2 and 5. So 2 over 5. Is that clear to you now?
Yes, sir.
Because it's 2, 3, 5 I want to identify, so it's only 2 and 5. Now, let's go for A intersection C. A intersection C. A and C. What is common to A and C? We have 3.
3.
So apart from 3, is there anything common to A and C? Let's check. There is nothing, yes? Is there anything?
No.
No. So that means for this circle, we're not putting anything in this place. Okay?
There's nothing.
Because it's only 3
No.
that is there and the 3 has been represented. Now let's go for B intersection C. B intersection C. For B intersection C, yes, are you there now?
Yes, sir.
Okay, very good. So we are trying to look at what is common to B and C. So what is common to B and C now? 2.
3.
Okay, 3. Yes. Next.
12.
12. Okay. What about 6?
Okay, yes, 6.
6. Yes. 6. Yes. 12. Right.
Yes, and 15.
And 15. Very good. 15. 15. So we want to put it in B intersection C. So we need 3, 6, 12, 15. We've already seen 3. Now remain what? 6, 12, and 15. So I'm going to put 6 here, 12 here, and 15. You get that?
Yes.
Very good. So we've represented all of these. Now let us consider our A. What are the elements of A? 2, 3, 5, 7. Yes. You will see. In the circle of A, I already see 2, 3, and 5. Yes or no?
Yes.
So what remains? 7, 11, 13.
13.
Yes.
17.
And what?
19.
What about B? We have 1, 2, 3, 4. So I didn't have 1 anywhere here. So I'm going to put 1 here. I'm going to put 1. So 1. What next? 2, 3. Then I need 4.
4.
Yes. What next? 5 is already here.
5 is there.
So I need 6 is here. What about 10? 10.
10.
10. What's the next one? 12, 15,
20.
and 20. So I've seen 12 and 15. So now remain 20.
20.
Now, let's look at this empty space. Let's check if there is anything in the universal. Okay, remain C. What are the elements of C? 3, 6, 9, 12, 15. So I've seen 3, 6, remain 9. I've seen 12, 15, remain 18.
15.
Now let's check from 1 to 20. If there's anything in the universal that is not here, then it's going to be in this empty space. Is that taken? Is that taken?
Yes.
I mean, okay, very good. So let's check. 1 is 1 anywhere? Yes. What about 2?
Yes.
Yes. 3, 4,
Yes.
then 5, 6 is there. 7 is there. What about 8?
No.
There's no 8.
No.
What about 9? Yes, we
Yes.
have 9. 10. What about 11? Yes. 12. Yes.
Yes.
13. Yes. What about 14?
Yes.
There's
Yes.
no 14.
No.
We have 15. Do we have 16? No.
No.
What about 17? Yes. We have 18.
Yes.
We have 19, and we have 20. So these 3 elements are not in any of the circles. So now let us quickly revisit our question because of the time, and I'm going to end this class, then I will send the link again so that we can continue. Is that it?
Okay, sir.
Okay, now the question says find A intersection B intersection C. I think we've been able to find that.
Yes, sir.
It now says find A intersection B, and we've been able to find that as well.
Yes, sir.
The third question says find A union C. Yes, A union C. Union simply means combination of everything in A and C without repeating anything. So A union C will be given as the total of A and C without repeating anything. So let's look for A and C. We have 2, 3, 5, 6. 2, 3, 5, 6. What next? 7, 9, 11, 12. 7, 9, 11, 12. What next? 13, 15, 17, 18, 19. 13, 15, 17, 18, and 19. And the last question say A union B union C complement. A union B union C complement. This simply means what is in the universal and is not in A, B, and C. Yeah, what are those things?
What's okay?
That is in 1 to 20, but it's not in A, not in B, not in C.
14.
Yes, we have 8, we have 14, and what? 16. Yes or no?
Yes, sir.
So can you tell me one importance before I end this class? Can you tell me one importance of Venn diagram?
For arrangement of the sets.
Yes, it makes your answer come out live. Yes or no?
Yes, sir.
Very. So do you understand everything I've explained?
Yes, sir.
Okay, do you have any question before I end this?
No.
Okay, so I'm going to end this class now. Okay, wait. Yes.
Sorry, sir.
Yes.
This complement.
Yes.
There used to be another sound that looks like
yes,
I.
which is prime. Yes, they call it complement or prime, so it's the same.
Oh.
It's the same.
Okay.
So thank you very much for this time. I'm going to give you another link so that we can. Let me try to get this note so that at least spending the time that you're going to get the video. The video is for proper explanation. So let me get you the notes also in your WhatsApp so that you can put it down even as I end the class. So I'm going to have your goodbye for now. So bye.
Okay, sir. Bye.
Okay, so I'm going to send you the link. So just be patient while I see the second question. So example 2, question 2. Question 2. Yeah, this is a little bit lengthy, but let's see how we go about it. So look at this question. Please don't write anything like I said. The following list shows the preference of 1,102 people at the end of the year party organized by the management of the college. 99 like this, 96 like this, 99 like this, and then 95 like this and this and that and that. Okay, how many people like none of the three? Juju only, anything but Afro, only Fuji. Exactly 2 kinds of music. So even if we cannot finish this question because of our time, I'm going to just try to show you the Venn diagram. Then I would expect you to try your hand on it so that by our next mathematics class, you'll be able to we'll be able to look at it together. Is that okay?
Yes, sir.
Okay, very good. So I'm hearing some background dragging, clinking, or noises around you. So please try to reduce that. Now, to attempt to solve this, all we want to do is to draw a Venn diagram. The first step is to draw a Venn diagram to be able to identify what we are looking for. So let's assume this is our Venn diagram, and our universal is 1,102. So as our universal is 1,102, we have 3 branches of music. So we're going to draw 3 circles as well. So the first circle, meanwhile, that means so the first circle, second circle, and the third circle. Now, the first question says none of the 3. Well, this is the region of none of the 3, the empty space here. And the next one says Juju only. This one says anything but Afro, that likes all others but doesn't like Afro. And this one says exactly 2 kinds of music. That's the kinds of music. Okay, we don't know how many people like the 93, or was it stated there? Okay, 93 like all the three. Very good. So I'm going to put 93 here because 93 like all the three. And the first brand of music mentioned was Juju music. So I'm going to use J for that. Next was Fuji. I'm going to use F for Fuji. While the last was Afro. I'm going to use A for Afro. Now, it now said 96. Okay, forget about all these first set of numbers. Then 95 like Juju and Fuji. Okay, in Juju and Fuji must be 95, and I already see 93. What remains? That it.
Yes.
Very good. Then the next one, 94 like Fuji and Afro. Fuji and Afro is the circle 94, but 93 is already here, so I have only one left. Okay, very good. Then 93 like, okay, 96 like Juju and Afro. Juju and Afro is 96, this is 93. What remains here? 3. So I need to know this place now. I have seen 95 in the circle of Juju. How many totally? That's 99. Is that the case? So
Yes,
since that is 99, I have 93, 94, 95, then plus 95 plus 3 is what? 98. So this remains only 1. Is that the case?
Yes, sir.
Because the whole circle should be what? 99. Then 96 like Fuji music. Fuji should be 96. This is 93, 95, 96. That means nothing is in this place. Is that it?
Yes, sir.
Very good. Then for Afro, how many? 95 like okay, 99 like Afro. So if it's 99, let's check it again. 93, 96, 97. So what remains? 2. So let's now attend to our question. Let's try to calculate all of these numbers. 1,102. So let me tell you, this is 102. The question is supposed to be 102, not 102. Okay? It's 1,102. So we're going to try to add all this together and take it away from the universal. So 93 plus 3 is what? 96. I have 97, 98, 99, 100. This is 102. Now I have 102 here. If I take it away from 1,000, what do I have? From 1,102. So that means I have 1,000 that doesn't like any brand of that music. So the answer to the first one is 1,000. Those who doesn't like any brand of music. Now, those who like only Juju is the one that does not overlap between one or Afro is 1. Very good. So it's 1. And those who like all the rest but doesn't like Afro, they are all of these people. And since all of them are yes, no, those who like all the rest but does not like Afro at all, they are all these people that are here. So they are 100 because this is 100. So we have this one as 100, and this one say only Fuji. How many people like only Fuji?
None.
None. That is 0. That's an empty set. That is 0. And exactly 2 kinds of music. Okay. This like exactly 2. This like exactly 2. And this like exactly 2. That is 3 plus 1 plus 2. And that is 6. So that means with that, we're able to tackle the question in the limited time. So is that clear?
Yes, sir.
Okay, very good. So I think we should be able to meet on Wednesday again for another class. Before you are going to resume your school next week, yes or no?
Yes, sir.
Okay, very good. So we're going to meet on Wednesday again. Then when you fully resume school, we're going to be meeting on Friday and Saturday as scheduled. Okay. Thank you very much.